Let's say that we have some solid water or ice, and we want to melt the ice and turn the solid water into liquid water. This phase change of solid water to liquid water is called melting, and it takes positive 6.01 kilojoules per 1 mole to melt ice. This change in enthalpy is symbolized by delta H with a subscript FUS, which stands for fusion. So this is called the heat of fusion. Next, let's think about the phase change of converting liquid water into gaseous water. This phase change is called vaporization, and it also takes energy to convert liquid water into gaseous water. Specifically, for water, it takes 40.7 kilojoules per 1 mole of liquid water to vaporize it. And so this change in energy is called the enthalpy of vaporization, or simply the heat of vaporization. Let's go back and think about the structure of ice. Ice has water molecules in a repeating crystal structure, and the water molecules are held together by hydrogen bonds, so between these two water molecules here. When we add energy, we increase the freedom of motion. So over here is a picture of liquid water. So this is still held together by hydrogen bonds. These water molecules are still held together by hydrogen bonds, but we no longer have a crystal structure. So we have increased freedom of motion. And it takes energy to disrupt that crystal structure. Next, let's think about converting liquid water into gaseous water or steam. When water's in the gaseous state, there are no more intermolecular forces between the molecules. There's nothing holding them together. And so it takes a lot of energy to pull these two water molecules apart. It takes a lot of energy to overcome these hydrogen bonds. And that's the reason why we have such a large value for the heat of vaporization. So it takes a lot more energy to completely pull these molecules apart than it did to simply increase the freedom of motion. So 40.7 is a much bigger number than 6.01. If it takes positive 40.7 kilojoules per mole of energy to go from the liquid state to the gaseous state, if we go in reverse from the gaseous state back to the liquid state, that same amount of energy is given off. So we can write 40.7 kilojoules per mole. However, since the energy is given off, we need to include a negative sign. Going from the gaseous state to the liquid state is called condensation, so we could call this value of negative 40.7 kilojoules per mole the heat of condensation. And if it takes positive 6.01 kilojoules per mole to go from the solid state to the liquid state, if we go in reverse from the liquid state back to the solid state, we would give off 6.01 kilojoules per mole of energy. And so we need to write in a negative sign here to indicate the energy is given off. When we go from a liquid to a solid, that's freezing. So this value is called the heat of freezing for water.